This is very exciting. Hi, this is Dale Peterson, and welcome to the Unsolicited Response Show. My guest for this episode is Ilan Gendelman. He is a co-founder and CTO at Siga OT Solutions. Ilan, welcome to the show.
Thank you very much. Thank you, Dale.
Well, I wanted to have someone really promoting the technology we're going to talk about on the show. So, I've told Ilan before the show that normally I encourage guests not to get too promotional about the technology, but here I want him to be a proponent of the technology because I've written some things. I would say that maybe there's fewer places where the technology is a fit. Most recently in my pivot to process variable anomaly detection article. So just with that as a caveat, I mean, he's not going to be singing the praises particularly of his company, but we're going to be talking about technology. So we'll get into technology that they do sell. And I've told him, that's what I want here. So why don't we dive right in? I looked on your site to find how Siga OT Solutions define the technology. And right there on the home page, there's a quote. Here's a quote from your site. By directly monitoring raw electrical signals as opposed to data packets, Siga platform brings new and unmatched visibility into physical processes. So when I first came into seeing Siga, both from your work and from Joe Weiss's, promoting what you do as a solution he believed in, the claim to fame was really this argument that you needed to monitor the comms or the electrical signal between the sensor and the PLC, and then report these back via a separate channel for some sort of comparison. Is that a correct way of describing it, or would there be some other way that you would describe that?
I would say it quite a minimal way to describe it. I would actually call what you're describing as a feature in the product, but not the core product. We perceive ourselves as a core technology as process-oriented cyber detection, and which means our full focus is monitoring processes. Hence, what is manifested by what you repeat in your articles as level 0, but this is the manifestation. What we actually monitoring is not level 0. We're monitoring the real assets of the OT environment, the actual processes. We are doing this mostly by connecting a tapping to the level 0 information. But we're doing this not because of the predominance of level 0, but by a lot of the benefits this layer brings. Because first of all, we need information that we can 100% trust. So level 0 is not 100%, but it's as close as we can get to an untempered process information, especially when we're talking about non-smart sensors, which is probably most of the industry today.
But just to make sure I understand, where you're actually getting this data is not from the sensor itself, it's from the signal from the sensor to the PLC or a level 1 device.
Exactly.
So you're sitting there, you're tapping that line and then sending it back over a separate network, not the level 1, level 2 that's actually used in the process control in the ICS. You actually have your own communication network back to your own Siga platform.
This is the most preferred solution. It's not a required part, but this is definitely strengthening the solution in terms of cyber. And the overhead of it is quite minimal. And it allows us, by duplicating pure electrical signals, to stay completely out of band, which means that even in most secure environments, even the most restricted environments in terms of cyber and IT and the limitations, we are delivering information up to your personal cell phone without any effect or adding any level of additional risk to your protected environment. So there are duplicates visions of the out of band, and there are many others. But there is no necessity for the product itself to sit on a separate network. Most clients do, some don't.
Well, so when I was thinking about this, I was saying, how do we evaluate what this monitoring of that position of the signals between the sensor and the PLC, or the sensor and the controller, whatever, the sensor and the level 1 device, what would that detect and what would it not detect? And starting down at the bottom, it wouldn't detect a bad sensor or a hacked sensor, right? Because you would get the same signal that would be sent to the PLC, right?
It's very much relying on what we saw when we were installed. So we are completely unsupervised machine learning based product, which means what we see during what the client define as the training period, this is what we refer as normal. We do raise questions automatically to the client of suspicious areas during the training period. But if the client says this is normal process, this is what we learn. So if there is a malfunctioning or a rogue or a tampered sensor from day one, and the client has no reaction on it, yes, we will not notice it. But if the sensor changed behavior for any reason at later period, we will definitely notice this.
Right. But what I'm specifically saying is, you're talking about more the back end processing. I'm saying, for example, you could do that you would have the same data coming from a historian or an ICS or something like that you would from that tap if
Not at
the
all.
sensor was bad.
Not at all.
Why not? If the sensor sending back saying, it's 100 or whatever
Yes,
scaled value you want.
in that sense, you're completely right. But
Yeah,
you're completely right. So the whole chain will see whatever the sensor is sending. So
right.
if the sensor for some reason sending wrong information
Yeah.
continuously, very a process kind of physically makes sense, then no, we won't notice it. But you won't see on the higher levels, as the historian, as the PIs, any other solutions which sit high in the hierarchy, you won't see the level of a detailed process information that's actually required for real process detection. This is the second reason why we focus on level 0.
So you're saying just the granularity of rather than getting samples, you're getting a more rich data stream, more analog kind of data stream
Reach
there.
as required, exactly.
Yeah.
Because it's a completely different volume, completely. I mean, and especially if we're talking about brownfield. And
Yeah.
again, this is probably most of what is in the field there. You see way more granular, consistent, and very clean data coming from process level.
Mm-hmm. So I understand that. I think the value of that not enriched data, because you're not adding anything to it, but more, what is even the word I want to use here? It's a more, it's not a sampled set of data. It is
Yeah.
the full set of data. So you're getting a more continuous stream, and perhaps for some types of sensors and some types of processor or some types of processes, that could be of greater value than others. Right. I mean,
From our
there's some things that don't change that often, that
yeah.
you would, you'd say, yeah, the fact that I'm seeing it only every 200 milliseconds up at level 2, versus
This is not what
every
you'll find.
millisecond.
No, this is not what you'll find in the historian. So first of all,
Well, you don't have to look at the historian. You could also pull it from the process itself, right?
yeah, but again, then you meet different channels, different limitations. You do
Yeah.
lose the level of trust you have, and you are under the various restrictions of the pre-programming. When it's being sent, what the threshold, is it being sent, how do you refer if it's not being sent, is it normal, is it abnormal if it's not being sent? So there's a lot of questions coming up from internal logic implementation. Moreover, yeah, go ahead. Yeah. So stop you when
No.
you...
So I think the word that we're saying here is that you're getting a higher fidelity signal is probably the word I was looking for.
Yes.
So there will be there. So the value there would be if you had a bad sensor or a sensor that was being spoofed or attacked, and you could detect that through a higher fidelity signal, maybe then there would be some value of someone attacking the sensor or a bad sensor. But short of that, if you're able to detect that same thing with the normal fidelity up at the high available in the data at the higher layers already, then it's more the back end processing that's detecting it. You don't necessarily need that fidelity. So that, to me, that's a question I'd have to ask some process people how likely that is to be a value. And my guess is it's going to differ quite a bit by process and by sensor. The value of that fidelity in the detection of a bad sensor or an attacked sensor.
No, we are not. This is not our target. We are not targeting as a primary target the sensor level. We are protecting the process level, which means if you have an attack on any level above level 1, including especially level 1, the end game of an attack is manipulation of the process. We are looking on the outcome of any such manipulations. So we are mostly looking not on a rogue sensor or an attack on level 0, but we are looking on any level of attack, how it's manifested on process levels. So if we are based on information coming from level 1, level 2, any level, it by definition, it's not necessarily the right information.
Right. So I had my other cases. So I said bad sensor or hack sensor. I had this tapping at that level. No, that wouldn't help. But you clarified it could in some cases because of the fidelity. Then I had, for example, changed value in a PLC. Yes, changed value in level 1 or level 2 comms. Actually going over the network. If someone was man in the middling the information, then you would identify that, or a change value in a level 2 computer. So basically anything spoofed or monitored sensor data on the higher side of that tap would be detected, whether it be at the PLC, the comms network, some level 1 or level 2 device. You would say, hey, my tap is showing me this value. The ICS somehow sees this value. They don't match. That's showing that there's something has gone wrong in that process of sending that data, whether it's an attack or some flaw in the system, wrong programming, bad comms network, whatever.
This is very true and a very specific feature. So the comparison feature is kind of one of the features of the system, but this is not the core feature of the system. What we're doing, we are claiming a very simple set of claims. So in your article, in your second article, you refer that probably the first thing you recommend is the barrier protection, putting in place as kind of a risk reward balance.
Right.
So once this is in place, the whole target of this and everything you mentioned afterwards is to keep the attacker outside, which is critical, vital, and important. But because we are protecting the OT environment, which is for quite a long time is quite clearly a strategic target, you should assume that on the higher end you're facing a very persistent attack. which means that the barriers you put are not sufficient and the attack vectors are endless. There's no point even going an attack vector after attack vector, because we are talking about a solution which is agnostic to the attack vector. So once an attacker is in position, his primary goal is affecting the process. Yes, he wants information. Yes, there is other things. Yes, he can use any form of affecting the HMIs and the control. But at the end of the game, the grand prize is affecting the process. And once he is inside, and we should all assume that he will be inside, he is able to take full control of the asset. Moreover, he can do it with no limit of time, because once he is in control, within sufficient control, he can fully set something happening to perform something on the asset level and report up to both the cyber solutions and to the operation solutions, all monitoring the process, whatever you choose to. And this is the core scenario, which is completely agnostic to the attack vector. This is what we are looking for. This is why we're in place.
Okay. So I'm with you sort of on that. I guess I would say that, just going back to the article you referenced, the first couple were protection. And then I think I had recovery. Being able to recover was like critical, number 3.
Agreed.
And respond was there. And really what you're talking about isn't so much protection. You're talking about detection.
Definitely.
You're not stopping anything. You're just detecting that this data you're seeing in your ICS is not matching the physical process. There have been changes. So then it becomes more a question, I think, for me, okay, this is going to cost me some resources. Is this my most efficient risk reduction to deploy this second sensor network? Because I have to deploy the taps, and really to get most of the benefits, I have to have this separate network. If I send it over the same network, a lot of the same attacks can potentially do it. So if that's what it's there for, I would want this separate network. What kind of cost are we talking about on a per sensor? I know there's going to be a wide range, but if you were to characterize it, what kind of cost per sensor am I looking at?
I have to say it's even hard for me to say from the top of my head, but let me just focus on something which is critical to your description.
Okay.
This whole paradigm of the levels of risk are basically a multiplication of how much reduction do you get per dollar on your risk level.
Yeah.
But obviously, it needs to be multiplied by the damage, the potential damage. Because even when the risk is low, but the potential damage is huge, it obviously affects the evaluation of the risk. So what we're saying is the overall cost, not only in money, which it's hard for me just to pull the numbers, but in terms of effort, of managing effort, of installation effort, of all the effort of installing a solution, you might be even surprised how little is it. Because we are out of band, because we are completely agnostic to the control system, to the control protocol, to the control, the manufacturer, the year of the PLCs, everything, in a matter of a couple of days, we have a fully operating system. And this includes everything, includes all the implementation, includes all the aspects of people working around. So the only actual minimal physical aspect is the isolators installed. It's not a duplicate sensor, it's the isolators installed on the both sensors and actuators. But again, only on a small subset. We are not duplicating the entire network. The core of the technology is extracting this valuable detection for a very small subset in a realm of 3 to 5, 7% at max of the sensors. Just like for a sense of feeling, in a GE Mark V turbine, we are installed from thousands of IOs on 70, and this was sufficient to validate very effective testing on the turbine. So this is the numbers we're talking about in terms of sensors. And the duplicating of the network is not at all as a duplication. It's actually, in most cases, it's via a secure channels of cellular connectivity, working with a secure router for cellular connectivity, and getting with a very, very minimal hardware installation in place, which fully done by our integrators, the full solution is in place. And this is exactly the same solution for brownfield, for any brownfield, with no limitations at all. And we have installations on brand new sites of multiple types.
Well, I think it would be important to have some idea of the cost per sensor. And again, it's not just it's putting that tap in, it's running the communications and such. So I think because we're talking about comparing various detection and protection options. For example, there's a lot of other people doing detection. I could buy one of theirs, or for example, I could use your back end and just accept the data from the process rather than deploying this network. Or I could spend my money securing that PLC so it can't be spoofed and sending a secure channel back. A lot of places I could spend the money. So I think to me, it's really hard to evaluate it until you get that number. But one thing you said was new, and it's funny because I don't know if you know, I think it was S419. We had Joe, and I believe it was Amir from your company.
Amir. Yeah, Amir.
Yeah, Amir. Talk. And one of the things I pushed them to talk about, but they didn't, was what percentage do you need to monitor? So it's a very different cost benefit look if you're saying I have to monitor 100%. As opposed to 3 to 7%. And then the other thing I said is, if you could only monitor, and I was generous, I said 10%. How do you pick which 10%?
Oh, that's very important.
If you do say this 3 to 7%, how do you pick that? Is it strictly based on criticality? Or are you using some machine learning to look for interesting correlations? Are you spreading it across different level 1 devices? How do you approach it?
So we have two approaches. One which was developed together with Israel Defense Authorities, which is, as you suggest, is basically tapping first as a network solution, and based on that, analyzing various attributes of different sensors, and later on adding the physical layer. But this, though you might think this is kind of an easier way, it's a way costly way, and it requires much more effort from the side. What we've developed is kind of our technique of site survey, which is done very closely with the site engineers, and building very closely to risk assessment of the various processes. First of all, identifying the most critical processes by being critical, by their effect. And then on the critical processes, we are analyzing the subset of IOs, which can be sensors, it can be actuators, which have a certain set of attributes which are vital for effective detection. It's not necessarily only their criticality. It's also many other features of the information, such as their effect on the process working state or working mode. Their obviously their criticality, but also their interaction with other IOs. So this is done very methodically, and this is the only part when the actual site engineers need to be involved in the kind of setting the scheme for installation. Once we have the site server in place, and this is can be done completely autonomously through web wizards, but also we have the guiding team for that. So once this is in place, all the rest is happening completely automatically. So we are connected, we are getting information. As we gather information, we iteratively study, learn what we get. And as soon as we pass the threshold of qualitative data limit, we are starting to be effective. And this happens quite fast. And the more data we get up to a threshold, the more data we get, we are able to detect a more small deviations from process normality as was learned. And we're doing all that, and this is part of the core of the process of the product. We're doing all that very in line with the OT environment, which means we are maintaining all the time a very, very low false positive rate. And on top of this, on clients which are choosing this, we are offering the solution that you started with, is also the feature that compares in real time, not only whether your process is acting as you would expect it, but also whether your various levels are reporting correctly.
Well, it sounds a little bit, I mean, do you think this selection of which sensors and actuators to monitor is more art or science at this point to pick that 3 to 7%? It sounds almost like you have these kind of engineer wizards who work with your team and come up with something that has a scientific basis, but the process is different, similar, but you have different considerations across them, as opposed to saying we get all this data, we throw it in this machine learning algorithm and it spits out the sensors, which I would call more scientific.
I can tell you that as you well know, it took a while for even starting to convince the industry first to put cyber solution at all, and definitely for our voice to be heard of regarding process-oriented detection, level 0, etc. We thought that the first main challenge will be, as you described, the physical connection. Who would let us physically connect to its process those isolators? Amazingly, it's non-issue. And all this hardware part is well familiar by the engineers on site.
Yeah,
it's much closer to them than tapping to smart switches. Okay?
Yeah,
it's
putting
completely
in span ports. They don't do that every day. They do the other thing quite frequently. So I understand that.
So and then the second part was, how the hell would you know what sensor to connect? Who would tell us this magically, as you say, subset? Who is the wizard, the engineering wizard who will supply us this information? And again, we found out it's much easier than one would think. That the engineers on site have so much knowledge just waiting to be dug in if the right questions are asked. We never encountered real challenge in this sense. It's going very smoothly. And then you can say, whoa, guys, this is not science. This is not science. You kind of random pick. Maybe you just random picking it, and then you say it's all fine. So I'll tell you the opposite. Once you install, and you are much way familiar with that than I do. Once you installed any network-based solution, even in IT environment, and you say, hey, this is a machine learning-based mechanism, it actually learns the normality. Okay, and so maybe at the first, this machine magic was tested. At the beginning, as you wrote, people were begging for POCs, and then the POCs, tested, etc. But then afterwards, today, if somebody installs a network solution, it doesn't run testing on this machine learning magic. We are installed in any place. Every single day, every single minute, we're being tested. Because every time we have an alert, people are asking in very, very, very detailed manner, what did happen here? Is it important? Is it operational? Is it cyber? And the other vice versa. They're asking us, whoa, we just changed this process. How did you not notice this? How can it be? So we are continuously tested on this subset that we chose magically. Moreover, we ran till today, I think, 9 external full tests, including NIPA, iTrust. You're probably familiar with all of them, with amazing results, I would say.
Okay, I want to make sure we get to the second part here. I guess just from my standpoint, I think that the sensor selection if you put people on it, you're going to come up with, I think, something of value. But I think it's going to be heavily criticality based, and I think what we'll find in years, whether it's the back end that we're going to talk about more, is you're going to find these unusual correlations across things that maybe attackers would never think that they would need to spoof or need to attack. For example, the thing I saw once in a presentation at S4 Europe, where someone talked about the correlation between the pushing down the position of the accelerator on a car, the gas pedal on a car, and the revving of the engine. That's an obvious correlation. And if you were trying to fool someone, you knew you'd have to deal with both of those. It's these ones that are spread about on different controllers that I think will be interesting. But we'll see. That'll develop over time. It doesn't matter. It doesn't mean that you don't get useful information, even if it could be improved. And like any process, I'm sure it will be. To me, the most interesting thing you said was the 3 to 7%, because I haven't heard anyone say that publicly. Maybe I haven't been listening enough. I don't know what your buddy Joe would say if you said we're only going to monitor 3 to 7%.
Joe is not speaking for us. He's speaking for his own understanding of the arena. It's not a Siga employee.
I understand, but he's one of the big proponents of your technology, and he says we need this,
which is good for us. But I think,
yeah, I understand.
He didn't see any demo for a long time.
I would really like to see, though, some sort of cost per sensor, or cost per isolator, saying we put one of these in, we have to wire it back. On average, it's 50 to 100, it's 500 to 1,000, something, because then we can start to say, oh, the sun's rising and getting in my camera here. Then we can say, we can compare it against our other options. Right now, it's difficult. I guess a vendor who really wanted, or an asset owner who really wanted to do it, could get a quote, and then they would know. But it's hard for an analyst to judge that at this point. But let's pivot now to the area that I talked about in my article, because to me this is much more interesting than pulling the data from where you do. This idea of, we have all this process data, and we can start to look for process variables, of process variable anomaly detection, whether that be, again, something that could be a bad sensor, that could be a misconfiguration, that could be an attack. We saw that with a presentation with Digital Ghost from GE that was essentially doing that with their system. They had a digital twin. They said, not only are we going to look at this, but we have all these processes. We're saying, hey, this reading doesn't make any sense in our model. We think the reading should be this, and it would actually send it back to the control system where they could either act on it or investigate or such. So that concept is interesting. I assume you can bring data in from other sources besides your lab. So what other sources would you bring it in from, for example? Throw out a couple examples.
We have lots of various integrations. We bring it from tapping, from various levels. We can bring it directly from databases, from OPC, from various protocols. We are connected to serial connections. We bring information from every level of the scheme. But again, we are not focusing on level 0 as level 0. We are focusing, and all the research of the company is focusing exactly on what you're saying, is not only the detection, which is a small part of this whole aspect, the detection of the information, but the contextualization, the explainability of this alert, meaning what can you actually say about what you see as abnormal, not just it doesn't make any sense. Now, you spoke about GE, about it's almost godlike, Dale.
Yes, I have small holes in my curtain, and it's 6:30 here, and the sun's coming up. They're little pinprick holes that are hitting my camera.
That means everything.
Sorry. No. So so let's talk a little bit more about this. Are you, the GE example I gave was, a digital twin, a very sophisticated model looking at structured data that they had put context into. As I saw it looks like your analysis is more on unstructured data. You just bring it in, or are you also building models and structuring the data?
Just bring it in. Completely unstructured in this sense.
Okay.
We're well familiar with the digital tools from its early days. Then later we had discussions with the digital ghost guys. I think it's a very impressive project. But exactly as you described it in the article, it's a project. You need to construct a digital ghost. So it's a nice kind of solution, assuming you have a very well predefined control system and set of hardware and the whole setup, and you can just maybe with some reasonable cost duplicate the same model. But in most cases, this is far from reality, which means very, very high cost. That's my assumption. I never got a quote from GE, but I assume this is a very, very costly process. And this is why we didn't go, when we had to choose, we didn't go to this direction.
Well, then, so I can understand that for kind of the security aspect, saying this data no longer fits its previous pattern. But you also on your site, you talk about your platform providing predictive maintenance and asset performance optimization benefits. I would think you would need some of that modeling and some of that structure to do that. Can you do that without building that model?
Yes, we can, but that's the reason we do not define ourselves as predictive maintenance company. Our core value clearly relies in the overall cyber suite, the ability to identify this information, to give it the right context, to identify it with various manners, including the level 0, and to separate it with probability between operational and cyber events. But as an addition, and it completely correlates with what I told you about being tested every single day, we bring operational value just out of the box. And just today, we had a long session with a site which installed us purely for operational reasons to identify the abnormalities happening before what they mark as critical events. And we were looking with them on a very, very granular information, just like a bit by bit, looking what do we see abnormal, what do we mark, what trends we identify as being unknown before the event. And again, this is not our thing. It's coming out of the box. It's just, this is what it comes. It's saying, hey, this is happening strangely, and it's coming from this component. And if you look over time, you can also see the shift in its performance and its behavior, and not in single sensor aspect, but in the whole component behavior, the interaction, various, those exactly correlations that one would not expect. And see that if you look at the probability maps of how it was acting before in the few areas, working zones, now you have different working zones. And this is all handed to the engineering team in parallel to the benefit we bring to the cyber team.
Okay. I guess the final question I'd have for you is this second part, the back end that you're talking about. Now, we've talked about getting the information and the fidelity and that into your system, but the back end, there's quite a few competitors in different categories. For example, your vendors, we've mentioned GE, but Siemens, Honeywell, they're doing this sort of thing. The cloud, you're seeing Azure and AWS very aggressively go after this market. Historians, classically, the Pi team, they have cloud services doing this sort of thing. And even you have specialty systems. I worked with a company called Technip FMC that made subsea systems, and they were putting together, again, more models and structured data, but they were putting together systems to offer a lot of these things that we're talking about. So on the back end side, you have a growing list of competitors. I think a lot of people see this as where there's real opportunity to add value with this technology. What is it, unique about what Siga does that's going to lead someone to pick your kind of approach over these other, quite frankly, larger, powerful market presence people out there, or the specialty ones that already are in there with the customer because they deployed the system?
So it's constructed from a few aspects. First of all, again, we are very much focused from day one with not, again, you are talking, let's look separately on the backend, but we do not look separately on the backend. We look as the whole product. And it's combining from the start all over the ability to combine the various sources of information from including level 0 and lowest level information and combining this all in one platform, which from day one was constructed to be very, very autonomous, very, very unmodeled or unstructured in a sense, and completely transparent to what dynamics of process we're monitoring, and doing it in very, very cyber-focused manner. And we do not attempt to kind of go head and head with the large operation and predictive maintenance solutions. They are far stronger. They are much more oriented to specific solutions. This is not our arena at all. And as a mark, one can see that probably most of the players that you mentioned at some point, even today, are speaking with us on cooperations, on testing, on integrations. So and this is not only correct from them; it's also correct for the larger network monitoring cyber solutions. Again, because we are not competing on the same arena, we are very, very focused on what we do, and we have quite significant experience already in that, and we aim to be very, very good specifically on this aspect of the solution.
Well, it's funny you talked again about this accessing the data between the sensor and the PLC. If let's say you're right and my assumption on this has been wrong in terms of the value of that for years. And certainly I'm much more encouraged when you say it's a subset. That to me becomes much more interesting. But let's say you're right and that's recognized as this is where you really need to get the information. What's to stop, especially the vendors, your GE, your Siemens, your specialty houses, who are installing the systems, what's to stop them from just feeding that up into their models? It wouldn't seem like that technology, the concept was interesting, but the technology of sending data from that level isn't terribly difficult. What's to stop them from doing that if you convince them that you convince the world this is the right place to monitor?
So it's completely combined to what I said from the beginning. We are not a level 0 solution. We are cyber process oriented detection. This is our strength. This is our years of development and research. This is what we've developed. We are also have a lot of know-how of our engineering team, of our hardware, of installing it. And as a product, we are much more mature and set compared to what we have been like years ago. But at the end of the day, when we come to work, most of our people, probably all our R&D team is working on the cyber detection ability, building this whole aspect. So if you're asking how difficult it is for any vendor to put a duplication and tap to the information, not at all. This is not at all complex, and that's why we cooperate. One of our investors is Phoenix Contact. So we are working very closely with them. We're using their not only but their devices. But this is not what we do. All our research is what do you do with this very specific set of data.
Okay, well, Ilan Gendelman, I appreciate you being on the show. If someone wants to find you, are you active on any of the socials? I didn't see you on LinkedIn.
I'm not. You can find Amir. You can find Ilan Sosnovich.
So we've had your site up there. The site where you can get more information is sigasec.com. sigasec.com. That's sigasec.com. And I appreciate you being on the show, and you've enlightened me a little bit. I think that one factor was huge, and I'm gonna really dig in, I think, a little bit more. If you have any white papers or anything on
Definitely.
the selection of that 3 to 7% or 10% or whatever it is, I think that would be interesting, and we would include that in the show notes. So if you have anything, send that to me. But thank you again for being on the show.
On this